So I'm a research professor now at the University of Southern California. I have appointments in both computer science and in spatial sciences. I did my undergraduate work at Syracuse University in computer science, and then I went on to Carnegie Mellon, where I did my master's and PhD both in computer science. The general area of work again is artificial intelligence. My PhD dissertation was on automatic planning, but I've since moved on. I became much more interested in the problems of sort of data integration and sort of compiling data from lots of different sources. And so there's a field of research called sort of the semantic web, which is really about, coming up with semantic representations of data. And so that area has interested me for a long time now, probably for maybe 20 years. And so a lot of my research these days is in this general topic that you may have heard of. It's referred to as building knowledge graphs, right? So Google has a knowledge graph sort of when you do a search query and it pulls information out. And then there's a whole field of work that's kind of related to that, where the basic problem is you have all this information that's spread out across all these different sources. And the challenge is, how do you pull it together in some kind of meaningful way? Because when you pull data from different places, it's organized differently, it's represented in different ways, they use different terms and stuff. And so one of the big challenges is how do you actually make sense of this data when it comes from different places? So there's a general field of research called, building knowledge graphs, which is what I've been working on. And that really involves, being able to combine information that comes from text sources, from databases, from things like spreadsheets, and being able to sort of pull that information to different places to make sense of it. And there's a bunch of sort of interesting sub-problems in terms of the research there that I've worked on and my students have worked on with me.
So, how did you get interested in research in the first place?
And that's a good question. So I think when I was an undergraduate, I had the opportunity to do they were like seminar classes with some of the faculty there, where the faculty would actually propose sort of interesting research problems. And then as part of the class, we would get involved in working on those problems and stuff. And, once I did that sort of early as an undergraduate, then I actually got jobs at the university working on specific research problems with faculty members. It was like that kind of transition from, first taking classes that involved some research, and then the faculty members were working on research projects. And this is at Syracuse University at the time. They didn't have a large PhD program, which sort of worked to my advantage. So that meant that, for the faculty to sort of pursue their own research projects, they often used undergraduates to help on the research projects and stuff. Then I got involved in working on specific research projects with some of the faculty and stuff. And I really liked that. So that was one of the reasons I decided I wanted to go to grad school.
Yeah, that sounds cool. And then I know you kind of already went over your research, but could you describe like one or two of your specific research papers?
Sure. Let me tell you about a specific problem we're working on right now. So we're working on a problem with the U.S. Geological Survey. So the U.S. Geological Survey is a U.S. organization. They do a bunch of different things in the U.S., but one of the tasks that they're given is to help identify where there are likely sources to mine for critical minerals in the United States. So these are things like nickel, cobalt, lithium. I mean, all these things that we need to make batteries today, right? We need a lot of these minerals and they're in short supply. And the US is a little concerned that we depend very heavily on other countries that control some of these critical minerals. And that potentially creates sort of a national security issue for the United States, which, if they were to cut off the supply of these things, then that could hurt a number of industries that we depend on the US. So the US Geological Survey is working on this problem of, where do you find these critical minerals in the United States? So we have a research project with them now. We have two research projects. Okay, one of them to build a knowledge graph of data about critical minerals. And I'll tell you why that's important. I mean, so the data is looking at sort of past data on where we found these critical minerals in the past and where they've been found across the entire world. And the reason that's important is because if you know where you found a certain critical mineral in the past, you can use that to predict where you're likely to find them in the future. Right. So you can use that to sort of figure out, okay, what are the characteristics of the regions or areas that we found in the past, and then use that to help using machine learning techniques to make these kinds of predictions. The part of our project then is to pull data from mining reports. The individual mining companies put out annual reports because usually they need to get investors. So they put in annual reports about for each of their mines, how much material they found that year, how much material they think is left on the ground. This is very helpful because this data tells us for a given type of mine and a given deposit type, how much material they actually found in the ground, right? So, and that's useful for sort of finding the most likely economically viable sites to mine. That's one source of data. The second source of data is people publish papers where they compile a lot of data about specific mines. Like the paper will be entirely about zinc, let's say. They'll review like every zinc mine in the world and how much material they found and what the grade of that material was. And so we pull that information. So the papers usually come with like a Excel spreadsheet with all the data. And so we actually have some methods to automatically import that kind of data. And then the third source of data comes from databases. So USGS actually has their own internal databases about all these different minerals and stuff. And so that's a lot of, information collected over, maybe 100 years. It's very detailed information. And so you pull that in. And, some of the interesting research challenges that we work on here are, for example, when we pull the information from an Excel spreadsheet, one of the challenges is you have to actually understand what the spreadsheet is actually telling you, right? It'll have a column of data that corresponds to zinc, let's say, and another column that corresponds to lead. And then there'll be a number in that column. And that number will represent sort of the percentage of the material found in the ore in that mine. And there'll be another column that will correspond to the actual ore. And one of the challenges is understanding the actual semantics of that spreadsheet. So I have one student who just finished his dissertation on this problem of basically being able to take a table of data and automatically come up with sort of what we call a semantic description of the contents of that table. And that then allows us to combine it with the information from the other sources, right? So then we can combine it with the information that's coming out of the mining reports or the databases and sort of, put it all together in a way that actually makes sense. And then we can answer questions. That's one example. And then a second project working on the same general problem, but it's a different research project. One of the other sources of information that USGS has is historical maps that basically are what they call geological maps. These are maps that were actually produced from mining companies. For a given mine, they'll actually show in detail where they found different minerals and how big an area those were over. And this is very useful for them as well because, knowing where the information came from, where they found sort of deposits of lithium or cobalt or nickel or so on, it shows up on a map, but these maps are in paper and maybe they've scanned them in, but there's no electronic version of them. They could actually sort of say, oh, where are the places that I found cobalt in the past? So one of the things we're doing is basically be able to take these maps and essentially automatically understanding the contents of the map. There'll be points, lines, and polygons on these maps. And so we have tools or techniques that we have students who are working on to automatically extract those things from the maps so that then you can turn them into what's called a vector data set. So then you can actually query the information and use it automatically and actually understand the text labels on the map. So those are two examples of research projects we've worked on recently.
That's really interesting. And then what do you enjoy most about your research?
I think the thing I enjoy most with the research is that it's always new and different. It's only in the last year that we started working on this problem of sort of finding critical minerals. So the research, I mean, the general topics that I work on are the same, but the application areas differ, right? And so, previously we did a project on building a knowledge graph for satellites in space. And so in each of these projects, what I really enjoy about it is each of these projects requires you to learn all this new information about the world. So I didn't know much about satellites, just like I didn't know much about sort of critical minerals. So there's always something new and different and interesting things to learn about. And that process is fun. And it's really interesting and fun to work with the domain experts. So like in this project with USGS, we work with geologists a lot. And so, they're always there to answer the questions and stuff. And they tell me how things work. And it's like this whole new area of knowledge and stuff that's sort of fun. Another good example is we did a project previously with a number of art museums. So we built basically a knowledge graph about American art, where we worked with 13 American art museums and pulled data from each of the collections of each of these different museums and put it all together so you could create these virtual museums and stuff. And that project I think was really fun because, we got to interact with, art historians and all these people that sort of work with art all the time and stuff. And so just really interesting problems that you get to work on. It's always new.
Yeah, that sounds really cool. And then which person or mentor in your field has made the biggest impact on you?
Oh, that's an interesting question. I would have to say Tom Mitchell. He was one of the people who was a mentor when I was in graduate school. But I listed him partly because when I was an undergraduate, I had read a paper that he'd written about machine learning. And I just thought this is really fascinating stuff. It was basically a really early machine learning paper. It was a fascinating paper about what's called version spaces, which is, ancient learning technology these days. It got me excited about the area of AI. But then it was great because then after I went to CMU, he then came there sometime after I came there and served on my thesis committee and was a great mentor for me.
He sounds really great. And then where do you see your research field expanding to, and what are some interesting topics that can be further explored within like the next 10 years?
Well, I think that this general problem of how we sort of process and combine data is really ubiquitous, right? So it's across every problem that people go to solve. People spend a tremendous amount of time sort of working, gathering data and working with data and getting in the form. And, machine learning has gotten really popular. Large language models have taken off. I'm sure you probably heard about these things. And I think that one of the things that's going to happen is kind of the merger between the current AI techniques, the large language models, and the work on knowledge graphs. So this is sort of, people refer to as sort of neurosymbolic research, where you're combining sort of the, the symbolic information, like the semantic information I'm talking about, with things like the large language models and stuff. And so I think that there's going to be a tremendous amount of interesting things that we can do by sort of merging these two areas together.
Okay. And then where did you start like your journey through research? So like what were some basic lab positions or internships that you had?
When I was an undergraduate, there was a instructor that was very interested in Prolog. A lot of interest in what was called logic programming, which is a set of languages. Prolog is probably the most common one that is still around. It's a bit for using and stuff. And so I got really interested in that. I mean, I took a class from that and I took a graduate level class on it. And then the instructor had some research projects that he wanted to do, sort of building his own sort of Prolog systems. That was like one of the first sort of research projects that I worked on. And there was a whole sort of larger research community that was working on sort of those topics at the time and stuff. So I got to go to some workshops where people were working on that and stuff. And so that was probably the first sort of early research project that I got involved in. But I didn't really start doing any significant research in terms of publication and stuff until I got to graduate school. And there, once you join a PhD program, the main focus of a PhD program is not so much taking classes. You do take classes, but the main focus then is getting involved in research and sort of, learning how to write papers and stuff. And so, one of the pieces of advice I'd give to students is find, even if you have to volunteer on research projects, find a topic that interests you or find topics that interest you, and then find people that are working on those topics. And then, volunteer your time to get involved. Because initially, until you learn a little bit more about doing research and stuff, you probably have to help out on some of the simpler things and stuff, but you'll learn a lot doing that, right? Just getting involved and understanding and seeing what other kinds of problems people are working on. And
Yeah, okay. And then did you have any pivotal moments in your research career that made you change topics or want to pursue a certain topic?
yeah, I can think of one in particular. It's a really good question. So, as I mentioned, when I did my PhD thesis on automatic planning, and I was heavily involved in that research community, the planning community. But I was becoming a little disillusioned with that community because it seemed like they were always focused on sort of solving these very abstract kinds of problems that weren't really based on real world problems. And we had a panel session at one of the conferences that I was a panelist on. I was making this point that I thought that it was important that we actually work on the problems that are, driven by the real world problem. And a number of people in the audience said, we don't actually care about the real world problems. We're really happy with the problems we work on. And I think this is a problem in academia. And this is my personal view, that sometimes entire communities get caught up working on some problem that has no real world application, right? But they can create this community and enough people write papers about it and they review each other's papers. And to me, I don't find that nearly as inspiring. And just to be fair, sometimes, you can do research like that and very abstract and not tied to the problem. And then you'll discover some application of it that in the future it'll be really useful and stuff. But not always, right? And one of the risks you take is that if it's too abstract from the real problems, that it may never apply, that you may be making assumptions that don't hold in the real world. So the pivotal moment for me was that actual panel, because at that point I decided that I didn't really want to be part of that community anymore. That, if they weren't really interested in working on the real problems, the problems of the world, that wasn't something that I cared for. And so I sort of refocused my research much more in sort of this more recent stuff in terms of building knowledge graphs and applying techniques to sort of real world problems. And I mentioned some of the application areas, like all the application areas I described those are real problems. I like working on the basic research and I like building the science to help solve those problems, but I always know what the real problems are so that I can always, use that to kind of make decisions about, well, is this assumption reasonable or not? Do I want to make this assumption? And it helps inspire you because then if you know what the real problems are, you know that once you can come up with a solution to those kind of problems, then you can make an impact. And I think, most of us want to have an impact.
And then how did you find your passion for research, and how would you suggest a high schooler to try to find their own passion?
Yeah, that's a really good question. I actually, in high school, I got interested in computer science and I went to a trade school in the afternoon where they would actually had computer science courses and stuff. I would say that's where I got my passion for computer science because to me, it was so much more interesting than all the other topics. I think in general, whether or not it's computer science or some other field, right? I think it's important for people to sort of try to search out and find things that they're passionate about that really interest them. And then I think that then helps motivate people and stuff. So, I was lucky that there was this program that I could get involved in high school. It interested me enough that I would stick around after the class and stuff. And then I got a job as a computer operator, helping run the computers there. And then I actually ended up programming things for some of the school districts and stuff. And so one thing sort of just led to another. And it wasn't really research per se, but it was more that it got me interested in the opportunities in computing. And that then drove me to pursue sort of computer science as an undergraduate. At the high school level, I think the thing that you want to try to do is find opportunities, find things that you're passionate about and that you can work on, that are beyond school, right? Maybe it's part of school, maybe it happens at school. I mean, take the courses in high school that it really excites you and then and look for opportunities. We've have some programs at USC that high school students can get involved in that do engage high school students in research programs and stuff. And so there's one program within Viterbi. So, wherever someone's located, right, they can look around at the local universities and stuff and see what kind of programs are available for high school students and then try to get involved. If that doesn't work out, then you can always reach out to faculty members of the university, like in the summer, and offer to volunteer.
Okay, so really just like explore interests.
Yeah, I mean, I think it's important to find things you're passionate about, right? I mean, because if you're not passionate about it, then you're not really going to put in the time. I mean, the thing about research is that in practice, it takes a lot of time. You're going to be more successful at it if you find things that you're actually interested in. One thing I'll mention is that, like, my daughter in high school got involved in, there was a robotics program. There was a course, and then as part of the course, then they would actually go and compete in competitions and stuff. And those kinds of programs are great. So there may be programs in the high school that you can get involved in. Getting involved in that can then lead to other kinds of opportunities and things.
And then what kind of skills do you think a high schooler could develop even if they don't have access to like a wet lab or tools that you guys have?
I don't think you need a wet lab. I mean, I think, for example, in terms of skills, there's all kinds of online materials and courses these days, right? So there's things like Coursera and edX and these sort of online programs where you essentially have people that are at the top of their field teaching courses online, and the courses are free. But I would say, find things that are aligned. It could be in any discipline, but there's courses on all different topics and stuff. So I'd say, you don't have to wait until you go to college to sort of start taking these classes. In high school, you can actually just go online. If you're interested in, for example, in computer science, you can learn how to program, right? I mean, Python would be an excellent language to learn. So you can go and take a course in Python. And that really positions you to do all kinds of things. But it doesn't have to even be computer science. It could be in chemistry or biology or any of these fields. So then if you want to get involved in a project or, you have more background in you're better positioned to work on things.
Okay. And then what traits do you think define a great researcher in their field? And what type of traits are you looking for in a potential lab member?
The kind of traits we're looking for are two things. One is sort of creativity, right? That, someone who kind of thinks outside the box and thinks about new ideas. I mean, one of the things that's interesting is that some students we get, they're really good at classes, they can take the classes and they do really well. But then you discover that if you give them an interesting problem to solve, that they're not really very creative about, the kind of solution. So one thing I look for is someone who kind of can think outside the box and come up with new ideas, and because I think that's an important part of research. And the second thing I look for is sort of passion, right? In terms of if someone has a lot of passion for a problem, then they're really willing to put a lot of time and energy and really think hard about the problems. And the combination of those two things, I think, is really strong.
Just for a final question, what kind of advice would you give to a high schooler who's looking to get into research?
I would say find opportunities. I have lots of people that contact me that want to work on research problems and stuff. I'm much more likely to take someone on that really shows that they've already done their homework. I might get people that contact me that, just sort of say, hey, do you have any research opportunities? I'd love to work on research. But I look at that and I think they don't even know what I work on, right? And so I'd say if you want to get involved in research, then you really have to do your homework, right? So it means you really have to figure out first get some basic knowledge about the areas that you want to work on. If you want to work with someone, you really have to go and look at their website, read their papers, I mean, understand what they do, and show that, some serious interest. And I get a lot of people that just reach out that clearly they haven't done any homework, that they just sent out lots of messages to lots of different people, hoping that someone will respond, say, hey, yeah, come do research with me and stuff. But I don't think that's actually as nearly as useful as if they've spent the time to really do their homework and understand, what kind of problems they want to work on and who works on that kind of problem and what have they done
Okay, so like you really just have to express your specific interest.
and do your homework, right? So, I mean, actually figure out, well, what area do you really want to work on? And then who works on that? And what do they actually do? So that when you reach out to someone to say, hey, I work on it, you could actually say, oh, I've seen your work on such and such. And, this really interests me. And, I've read the paper and I really would love to continue working on that. Although I want to be a little bit careful because sometimes what happens is I get people that do that where they've expressed a tremendous amount of interest about something that I worked on 10 years ago and I no longer work on that. So you have to be a little bit careful, right? So you want to make sure that you're looking at what people are currently working on, what are their current problems and stuff, because researchers do change direction over time, and usually what they're most interested in working on is continuing or building on what they're currently doing.
So that's all the questions that I have for today, and thank you so much for meeting with me.